And I just want to let you know that this is not new material. This is old. In fact, the first part of this talk was given at ACCU in 2009. And essentially, this entire talk was given at ACCU in 2011. And I had some feedback from someone we all respect, Scott Myers. He said, you know what, lose the first section because it's not relevant. Except it's my signature, so I kind of have to do it, but put up with me, I'll go quick. And then he said another thing. There's this thing that's out of place. I don't want to tell you what it is, but I'm going to show you when we get there. I'm going to make a big deal out of it. And it's really quite important. But with that said, I'm going to get started. This is what's not working. Okay, come on. Why? Because I have this backwards, and I always do that. All right. Copyright notice, I just put that up there because, well, I did change a few slides. And this is the outline, but since you were already here and read this, I'm putting it up just for the camera to get, and then we'll proceed on. But the idea is I'm going to present some theory, and then I'm going to present some practical programming value that you can use at the end of this because we have an open source distribution. So that's what we're here for. The first half is theory, and the second half is real concrete practice. So what's the problem? Well, I do this stuff called large-scale C++ software design, and involves both logical and physical aspects. But today we're going to be talking about the logical aspects, which is why this whole thing is a little out of place. But nonetheless, this is part of what we do. And so there's logical functionality that we need to put into physical components. And we also have to be able to delineate this behavior in words, and we have to realize the behavior while keeping in mind physical dependencies among the components. So this is what I do. This is like my life. Everything is all about that. But if we don't get it right, if we don't call our libraries correctly, none of this matters. So this is really what the talk is about today. We're going to just quickly look at some logical and physical design aspects. Then we're going to talk about contracts. Then we're going to talk about our favorite, undefined behavior, and why it's our friend. I know that's heretical. I do that deliberately to keep you guys awake after lunch. And then we're going to look for real at code that solves real-world problems, even when people think it's not possible to do that. So keep an open mind. And I'm also going to try to go through this as quickly as I can because there are more than a few slides here. People probably know me. They've been to my talks before. I tend to be a little bit heavy on the slide count. The good news is that more slides sometimes go faster than fewer slides. And hopefully that'll be the case. So the brief review of physical design I want to show you. This is my signature. This is a component. It has logical and physical aspects. Logical is classes and functions. Physical is files and libraries. And inside these components, we have logical entities, classes and functions. And here we see a bunch of different components stacked one on top of the other. That's my cartoon, if you will, for physical dependency. I call these things bricks or components or whatever, but they do in fact exhibit dependencies such. When you look into one of these things, you've got a header file, you've got a implementation file, and you have a standalone test file. And the component proper is the pair, the .h.cpp pair, but still we want to be able to test the thing from an actual program. And there's something good about having a main to bring together all the functionality that's been factored out so far in terms of components. So this is what we're thinking about. This is our fundamental unit of design, logical and physical. And now just a quick look at notation that I came up with a long time ago, and I still like it. Here's just a quick intuitive idea of things. You know what a shape is. It's an abstract thing. Polygon is a concrete implementation. Normally, we wouldn't do this with value semantic types, which is an entirely different issue from this talk. But we're doing this to appeal to your intuition. So the first thing we know about is ISA. ISA is a relationship between logical entities, and a polygon is a shape. No problem. Then we have this thing called uses in the interface. A function uses a type in its interface if it names it in its signature or its return type. A class uses a type in its interface if any of its member functions use that type in their interface. So here we have a situation where we have a polygon uses point, we have a point list uses point, and a point list underscore link using point. Point list underscore link by our convention means it's local to the component, just as if it were somehow private, except it's at the same level. And we won't go into why we do that, but nonetheless, those relationships exist. Then we talk about uses in the implementation, and uses in the implementation means it's used in some substantive way, but it's not visible programmatically in the interface. If you look at this, a polygon might be implemented, in terms of a linked list, and a linked list might be implemented in terms of a point list might be implemented in terms of a point list link. And it turns out that the one that's inside the component doesn't have any substantial effect, and the reason for that is those two classes are already co-located, so there's no physical implication. Okay, then we have this very strange thing called uses in name only, and it does not lead to physical dependencies. It's a collaborative notation, but because shape is an abstract interface, it's possible for the shape to simply forward declare class point without ever including it, and it still works, surprisingly. So this doesn't have a physical implication, it's a logical one. Yes, sir? Oh, fair enough. Somebody should have taken a picture of that. I've never seen something look more like somebody raised their hand in my life, but okay, fair enough. All right, implied dependency. Once you have these logical relationships, you can infer from them the physical dependencies among components. So in this particular case, each one of those relationships, except uses in name only, causes a physical implication. Notice that these arrows are from box to box because boxes are physical and the bubble things are logical. Okay? And finally, once we have this, if we have an acyclic graph, then we can assign level numbers. And intuitively, things that don't depend on anything else are at level 1. Things that depend on level 1 things but nothing higher at level 2. And if you look at polygon, polygon depends on something at level 2 and something at level 1. So it's at level 3, not because of 1 plus 2, but because 2 is the highest thing that it depends on. So I hope this is intuitive. And again, this was just the signature of what I normally talk about, which I say all the time, every time. Sometimes I say much more than this. This was just a quick overview. So if there are no questions, here are some questions you might want to ask, because I wanted to have them ready because there's a lot to say. So does anybody have any questions about that? It's all good? Okay. How much time did I take? That's not too bad. 7 minutes. All right. This is something I did want you to take away from this. What's the difference between logical and physical design? That's really what I want you to think about. We're going to be talking about logical design for the rest of this talk today at both hours. So that's done. Okay, next thing, interfaces and contracts. So this is the next step in our progression that we're going to need to get through. So when we talk about interfaces, we can have interfaces for functions, for a class, or for a component proper. And so here's an example of something. This is an interface. These are types used in the interface. Okay, here's a contract. Now, I don't expect you to read this. I'm going to read it shortly, but just to give you an idea. Here's a date class, and you can see the interface. The public interface is here, and here's a contract. And here's some more contract, and some more contract. We're going to get back to this in a second. I'm just trying to orient you. Okay, and here's a component. And here's the public interface. We have the public interface of the class plus whatever free operators are located within the component. So again, interface, then more contract, right? Because each of the functions needs a specification of what its semantics are. And here's some more contract. More contract. Okay. Now we need to talk about preconditions and postconditions. Just have a question. Does anybody have a negative reaction to the term designed by contract? Does that mean something bad to anybody here? Be honest. Seriously. I was told by a very reliable source that some people have a reaction to design by contract and say, oh, no. Don't, yes?
It makes me think of Eiffel.
Okay, fair enough. Makes me think of, that's where I first learned about it, but fair enough. Does it make you feel bad about it? Does you say, okay, wait, Eiffel, bad stuff. I just want to get it. No. Other than that, no. Okay, good. So anybody else have a bad feeling, leave a bad taste in their mouth when they hear design by contract? Yes? I don't know. Maybe. Okay, doesn't sound like you guys are really put off by the idea of design by contract. Anyway, good. Then I won't try to defend it. I'll just keep talking. So here we go. So we've got preconditions and postconditions for a function. Let's take square root. Okay, is this a precondition or a postcondition? Precondition, excellent. So for a stateless function, it's a restriction on syntactically legal inputs. It's more than what the compiler knows. It's what we said. We're talking to another person, right? Okay. What is this? Precondition or postcondition? Postcondition, okay. And for a function, stateless functions, it's pretty much what it returns. It could return it through the argument signature, but for all intents and purposes, it's what it returns. Okay. Objects. Objects make things a little more interesting. A precondition is what must be true of both object state and method inputs, otherwise the behavior is undefined. Okay? Now what's important here is that it involves not just the arguments, it actually involves the state of the object. Let's take a familiar class like a vector of int. Vector of int has some functions where the only precondition involves the state of the object. Can anybody think of a function on vector that has as its precondition, sir? Front. There you go. Perfect. So the precondition is if it must not be empty, right? Excellent. Okay. Postconditions are what must happen as a function of object state and input if all preconditions are satisfied. Okay. This is also known as essential behavior. And there's a very fun gentleman to listen to named Kevlin Henney who pointed out that essential behavior is not the same thing as a postcondition, is a superset, because there are other things that go on, like time complexity, thread safety, other things that are not something you can observe in a single test at the end. Okay. Now, this is interesting stuff. People have heard of undefined behavior. People have heard of now essential behavior. There's a third. There's something in the middle. What if it's not essential, but it's not undefined either? Then what? Okay? This is stuff. Stuff happens, right? There's stuff that the implementation did something, but we didn't say what it did, so it's weird stuff. It's not a good thing. It's not the end of the world, but it's not a good thing. So let's take a look at this contract, okay? Format this object to the specified output stream at the absolute value of the optionally specified indentation level and return a reference to stream. If level is specified, optionally specify spaces per level, the number of spaces per indentation level of this and all of its nested objects. If level is negative, suppress indentation of the first line. If spaces per level is negative, format the entire output on one line, suppressing all but the initial indentation as governed by level. If stream is not valid on entry, this operation has no effect. So now, please take a look while I get a drink. Does this have any undefined behavior? What if level is 0? Okay. What if level is 0? Is that undefined behavior? Does anybody think level 0, undefined behavior? This is a hard question, or at least without having heard the talk, it's a hard question. So let's go to this one. Any non-essential behavior. If you thought that other one was hard, this is harder. Now you really have to think. Is this a complete contract? Doesn't tell you what is returned. Now, I made this deliberately hard, so it's okay if people don't find it immediately. Go, if you speak up. Well, now it is true. It's true that sometimes we take liberties. If the code contributes to the contract, sometimes you don't say it, sometimes. I'm not saying whether that's good or bad, but we, for example, here, try to word things in a way that it cooperates with the interface. We try. Anyway, the point that I'm trying to make here is if you read the last line, if stream is not valid on entry, this operation has no effect. But what if stream becomes invalid during the operation? Then what? Is it undefined behavior? No, it's not undefined behavior. But it's not essential behavior either because we didn't say what happens. So it's something else. So it's neither undefined nor essential. Okay, so the contract doesn't say that. So guess what, as a client, you better not rely on that because it might change. It's not specified. All right, so now let me ask you a question. Does this function have any undefined behavior in it? Any undefined behavior, what do you think? Anything? Any clues? Okay, so maybe it has some undefined behavior. How do we know? It said so. Good. Does this function have any undefined behavior? Oh, thank you for saying. So you're saying that this has undefined behavior. How do we do that? How do we get to that undefined behavior?
By giving a date that was constructed with the previous constructor.
Okay. Well, what about this up here? This class implements a value semantic type representing a valid date between the dates 111 and 9991231 inclusive. That's an invariant of the class. Okay, so how would we violate that invariant? This is great. This is exactly what I was hoping for. So if you can, but you can't because there's a precondition that says you can't. And now the question is, must the code itself preserve invariance even if one or more preconditions of a method's contract is violated? Now, what is your answer to that? Must it? I mean, we're good programmers. I don't mean must it. I mean, all right, you're working for a good company. Must it? Ooh. You would not. Okay? How about this? I will put an absolute on it. Because it doesn't have to be true all the time, and it can't be true in some cases. It simply cannot. Because the range of checking goes from very cheap to impossible with lots of things that are really hard and would never make sense. Like I just cast some garbage address to a date and pass it in. We don't even talk about such things. That's just nuts. We also don't talk about things that are so wildly expensive that you don't even know what the complexity is. I mean, maybe it's doable in theory, down to, hey, wait, I've got something that runs in log time, but that check is linear. You can think of cases like that where you say the data must be sorted and you're going to do a logarithmic lookup. So you can't. So no, just no. Sorry. What happens when behavior is undefined is undefined. This is really, really, really important. I'm sure Marshall won't disagree with me. All right? So, what is design by contract? If you give me valid input, I will behave as advertised. Otherwise, all bets are off. Okay? When we do contracts, meaning when I do contracts, I look at 5 things. I look at them in this order. They're not separate sentences. The first thing is what it does. And we call out every parameter that is not optional in this first sentence. We do it in a very stilted way. We do it every time, and we make sure we do it exactly the same way every time. And it's first. The next thing is what it returns. So what it does, what it returns, and we do it in an imperative voice because we're mimicking the function signature itself. The third thing is where we go off into the semantics of the function. We elaborate if necessary. That changes the tone. When you're reading our function doc, you will see by the tone of the sentence whether you're in 1 or 2 or whether you've gone into 3. The next one is undefined behavior. And we don't say the behavior is undefined if. We say the behavior is undefined unless. The reason we do that is we can string together a bunch of things that if you don't meet all these cases, it's undefined behavior. And then we have a little, in the implementation, we have the option to assert that. And I'm using assert in quotes because I'm going to get to there, that's later. We have the option to assert that. Because anything's okay if you give me something that's not what I told you it had to be. If you violate the preconditions, the library is entitled to do whatever it wants. Does anybody disagree with that? You give me bad input, I can do what I want. I might want to do something good, I might just do nothing. I might, who knows? But anyway. And the last one is, it's a non-normative note that says, hey, by the way, Mr. Programmer, if I didn't make myself clear, this is what I meant. Or you might want to go look at that. But that's not part of the contract, that's an oh, by the way. And this is part of every single function contract we write ever. Exactly this. Okay. Verification. How do we, as clients of a library, make sure that we're calling a function of a library in contract? Any ideas? How do we do that? My man. Excellent. There's another way. We can also assert in certain build modes. We could do that too. Don't have to. First one is the most important one. Thank you. We'll talk more about this later. Then, how about post conditions? How do we make sure that if our preconditions are satisfied, that we as library developers wrote the code properly? Component level test drivers. Excellent. You guys are spot on. Last one, a little tricky, invariants. How do we make sure that our invariants aren't violated somehow? Either by running over memory or we have a bug in our code or something. How do we do that? For example, that the capacity of a vector is never less than its size. How do we do that? I'm sorry?
Fuzz testing?
What is that? What?
Fuzz testing.
Fuzz testing.
Wide range of tests with random inputs, automatically generated.
Okay, but how do I know whether the invariant was violated? Where? Where? Specifically where? You get 99%. Give me the last 1%. Where? At the act. Okay, so it could be in each method or it could be in the destructor. Because when we do testing, we're going to bring the object to every relevant state for testing purposes. Then we're going to let it go out of scope, and that's where we're going to catch it. So fuzz testing, fine with this. Or not fuzz testing, just thorough testing. Fuzz testing is sort of like, I don't know how to test. I'm going to try everything. No, you're always better than random, pretty much. I mean, I understand that some people feel like they can't go through the process of thinking about what they did wrong because they wrote the code themselves. That's another talk. And maybe talk with your therapist, I don't know. But you need to be able to objectively test your own code. And again, that's not part of this talk. There are four things. There's component level testing, there's peer review, there's static analysis tools, which are amazing. And then there's the fourth thing. That's what we're talking about today. Questions?
So why assert only in safe or debug modes?
Oh, does anybody want to, besides me, because we're too early in the talk to give away the thing. Somebody else, why do we assert only in safe or debug modes? Yeah?
Well, at your example, a logarithmic lookup in a sorted array, you'd want to be able to assert that it's sorted, but you'd never want that at runtime.
That sounds like an excellent argument. Suppose you have a high-performance, multi-threaded thing going, and you put in this check that just makes it go to its knees because it just...
Right. 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 There's obviously lots of assertions that cannot make. Right. Right. But it seems like there are also other assertions that could easily remain on in production mode.
You really want to stay through this whole talk, I promise you. You really do.
I second that. 95% of the assertions stay on.
Oh, and he disagrees, and that's why this talk is so much fun. Because I have to make all of you walk out of this talk in agreement that you individually were right. And thank goodness John made that possible. Let's see if all of you can be right.
All right, one more.
All right, go ahead.
You're saying asserts in production code are good. Say you're an autopilot, some kind of avionics system.
I'm not saying
You get a
that
bad
inserting in
input.
production is always good. I am saying that inserting.
Okay, that discussion right there could lead to blows. All right, I would like people to look at these questions. These are the questions I want you to let me know, do you understand this stuff? By the way, we're doing excellently on time. I can't believe this. Yep.
Why wasn't assert listed for postconditions?
Okay, does anybody want to answer that? Why didn't we put assert for post conditions? Any ideas? Or, well, first of all, testing is how we assert the post conditions. Second of all, yeah.
You're asserting the preconditions because that's the part the user is doing, and you're trusting your library implementation. The library has promised if you're good, then I'm good.
Right. Are you saying that the assert would go at the end of the library code, or the assert would go right after the library call in the client code? I took it to mean the library. Now, if you're saying the client code, that's something else.
Okay, ideally, and maybe this is discussion for another time.
And now's the time.
That both the preconditions and the postconditions need to be asserted in a space in between the library and
Okay, so what you're saying is at the very end before the function returns, take all the post conditions and assert them. Remember what I said about essential behavior being a superset of post conditions? The other thing is that in some cases, solving the problem is much harder than verifying it. Can we think of a case where that's true? Something starting with an N and ending with a P? Right? You can check that in polynomial time, but you can't solve the problem. On the other hand, there are a lot of problems where solving the problem and then checking it are the same cost. And you don't know of two ways to do it. But if you did, you'd put one of them in the test driver. Because the idea is you don't want to double the cost of your function. Right? I mean, again, right? We're trying to save some, green, whatever it is. Well, anybody else? All right, I'm just doing this. I'm picking out one question for the thread of this talk that please, at least this. You know the answer to this, right? Does anybody not know the answer to this? What is the answer? No. Okay, good. All right, we're moving right along. Good contracts. Defensive programming, what is it? What the heck is this thing? Okay, that sounds very Eiffel-esque. All right, I'm going to claim this, just to get us started. I think it's redundant code that provides runtime checks to detect and report but not handle or hide defects in software. Please argue with this. I just threw this out there. Maybe it's wrong. Does anybody disagree? It's not enough, but does anybody think that's just wrong? Okay, explain why it's wrong.
Because one of the things that, one of the ideas I have behind defensive programming is handling malformed, shall we say, inputs. And that may not come from software, that may come from an input file or over the network or so on. And one of the things I think of in defensive programming is to protect the system against bad inputs.
Okay, so let me make a distinction. I took defensive programming and I put it here. What you just described, I wouldn't call defensive programming. I would call it programming. The difference is when you have an untrusted input from an outside line or whatever, it is not optional to validate the input. It's not optional. If you have somebody typing in a program and you say only valid programs that this compiler, or the only programs this compiler handles are syntactically legal ones. If somebody makes a typo, well, I told you had to give me a valid, program. That's crazy talk. So you wouldn't do that.
I use compilers like that.
Okay, but do you?
Invalid programs, they signal it by crashing.
How do you feel about this? Is it true that there are at least two flavors of this kind of good programming, because I don't want defensive programming to equal good. I don't want defensive and good to mean the same thing. I want defensive to mean you're defending against a client who didn't RTFM and is calling you, even though they're part of your company and you expect them to get that right, you're defending against something. And you're defending against that specific thing. What you're not defending is, okay, it's my job to take this off the line, process it, and if it isn't an attack, then go ahead. But if it is, kill it. And I think they're different. Or at least for the purpose of this talk, I think they're two separate concepts. Is that, okay?
I'll go with two separate concepts.
Excellent. Okay, what else could it be? Okay, now I'm saying that's not programming, that's design. Defensive design, like pushback. It's really hard to screw up pushback. Right? What are the preconditions on pushback? But there aren't any. You can push back. Okay, so that's defensive design. You can't get it wrong. You just can't. Defensive programming is, okay, you can get it wrong, and we're going to spend some of your runtime to make sure that you hear about it.
So I think what he's defining is when logic crosses the trust boundary, when the data is crossing the trust boundary.
Sure, totally agree.
That's when you have to validate your input. This is something where you're not crossing a trust boundary, right?
You're not crossing a trust boundary, but it's like trust but verify. So our application developers, we trust them, right? But they make mistakes, so we verify. The verification process is a runtime process in this case. We run some code to verify that they called us in contract, even though they're not allowed to because it's undefined behavior as far as they're concerned. Is that right? Does that make sense? Okay, go ahead.
Runtime is the only word that I took issue with.
Yep.
Because template metaprogramming, you can have redundant code and this defensive programming.
If it's a compile time assert, it is in a funny region because it costs you at runtime nothing, and it costs precious little at compile time also typically, and so it really isn't what I'm. It's kind of yeah sure we can throw that in for if you want. It's not important. The thing I'm trying to get at is people don't get upset about static asserts. They're fine with that. That's a good thing. They get upset about non-static runtime asserts, and that's what I want. I want people to get upset. They're not going to get upset with that, so it doesn't add any fuel to the fire. So I hear you. How's that? All right. All right. So next thing is defensive programming good or bad? All right. It adds overhead, but it can help identify early in the development process these wonderful defects. So it's both. That's what I think you said. It is good. It's both. It's yes because it's one or the other. It's certainly not neither. So, all right. Now, this is a tough one. Which is better? Design by contract or defensive programming? How about this? Do you ride the bus to school or do you take your lunch?
Another way of saying what I said.
It is. I don't think we disagree, happily. I think we're all on the same page. But sometimes people say stuff like this, and so I just want to point it out to everybody in no uncertain terms. Okay. Now, what are we defending against? Now, Marshall jumped the gun a little bit on me on this, but there's bugs in software that we use in our implementation, like ACE and Boost and Bloomberg's library distribution. Is that what we're defending against, the software we use, the standard library, the vendors? Is that what we're doing with defensive programming? Or is it maybe our own bugs that we introduce because we don't know how to program? Or is it misuse by our clients? What do you think? I'll tell you what, before you answer this, one of these is definitely not defensive programming. Which one is definitely not? Number one, I have some number. Who thinks the first one is definitely not defensive programming? Okay, who thinks that number two is definitely not defensive programming? Okay, and then the rest of you think that 3 is definitely not defensive programming? I'm scared. All right, well, it's not that one because that's how we deal with that with test drivers. Now it's between the first and the third. And the first one, if we have a buggy vendor, we have to give them some stuff, some annoying calls, or change our vendor or do something. But anyway, this is what I'm trying to say. I want defensive programming to be misused by our clients. What I'm defending against is somebody calls me on the phone and said, your code is terrible. You don't know how to write. I said, no, you don't know how to read. That's what I'm trying to defend against. And I cleaned it up a little bit because we're on TV. Yes?
Yeah, you've heard Shantz talk about that. He regularly gets a call. I found a bug in STD sort. And he says, your comparison function doesn't define a total order.
Yes.
No, I found a bug. No, your comparison function.
Right. Now, total ordering, awesome, right? Could that be checked programmatically? It's at that edge. Maybe theoretically, maybe, but no. All right. Pejorative terms. It's time for some pejorative terms. All right. Fat interface. I love this. It's not a good thing. I know there's at least one person who's written about it in this room. Anyway, to me, a fat interface is really, we blame the interface, but the implementation of the interface wasn't able to fulfill the contracts of the interface. That's unfortunate. Then there are these large interfaces. Large is bad. It's too much. Non-minimal, primitive stuff. More than that, it's too big. We need to make it smaller. Well, now we have wide contracts. Wide. This is not a new term, by the way. This was presented in 2011 for all to see, and now we're starting to use this term when we talk to other people in the Standards Committee. We use this term. We use it openly. And in fact, Scott Myers in his next book will have some discussion of what wide versus narrow means. Now, I made up these terms. I absolutely made up these terms. I take full responsibility for making up the terms. Oh, well. Fat was taken, large was taken. I'm going with wide. All right. Narrow contracts imply undefined behavior. How so? All right. What should happen here? What do you think should happen if I do this wonderful thing that, of course, we all want to do secretly? Reformat your hard drive. That's what you'd like it to do that. Don't hire this man. Please. Any other ideas? What might it do? It throws an exception. All the time or just occasionally? All the time. In every platform, every build mode forever. In every program. Go to terminate. Okay. I heard assert. Okay. Anything else? And ideally it wouldn't compile. Okay, but that's a library contract. It's not a language failure yet. Well, there's nothing against the language here. It's a violation of the contract. That's it. You see the difference? All right, how about this? It's our library, and we say, you give me 0, I'm going to return 0. I promise I will return 0. No. No, I actually haven't. Think about it. Before it was undefined. It's still undefined, and I'm going to do that. You're going to try to stop me? I mean, it's undefined behavior. You're saying I can't do anything but not that? Of course I can do that. Right? Because it's undefined behavior. Marshall, back me up. It's undefined behavior. I can return 0. See, this is wonderful that this man is in here. Okay, now this is what we're saying. If not s returns 0 makes it a wide contract because there are no wrong answers anymore. You pass whatever you now. If it's not a null terminated string, it will be unpleasant. But you get the idea. Now, yeah. Is that really true? What if you go off a page segment? No, you can actually. They will. You're right. It is terminated. It's not null terminated. It's something else terminated. But all right. So anyway, what about this? what, is there anything wrong with this? Why don't we just do this and stop complaining so much? Oh, just fix it like this and be done with it. Is that a good idea? Marshall.
This doesn't make it, give Sterling a wide contract.
Why?
Because, as you said, you can pass in a pointer that points to, say, unmapped memory.
All right, so let me address that issue. There are, just like when we're doing contracts, we don't, in every contract where we pass a pointer, where the pointer is required not to be what you just said, but actually refer to an object, we don't say in the contract that it has to be a pointer to a valid object. We don't say that. But what we do say is if it can be null, we explain if pointer is null, then we do this. If you're a client and you see a pointer and you pass in a null pointer and the contract doesn't say what happens, oh, I'm sorry. That's your problem. So we save all of these trees for all the paper that would have been printed out, saying that every single time, and references too. You could say the reference has to refer to a valid object. We don't do that. Now, I grant you that there are a lot of nuanced things you could do that would give you undefined behavior or lead to undefined behavior. We're not going to talk about that. I'm really trying to keep it relatively clear so that you understand that this, as it is shown right here, is a wide contract modulo that it has to be a null terminated string. So it's wider, okay? But without it, it's narrower. You at least give me that. Anyway, the precondition, the reason I say this, wide contract, you wouldn't try to assert a precondition, ever, with a wide contract. But with a narrow contract, you would. That's kind of the intuition. Okay? Anybody else? We're doing okay on time, so if you guys have a question, go ahead.
So I'm not sure about wide or narrow, but I would say this is bad simply because returning 0 actually has meaning. It could point to a valid string where it's just the first thing is the null terminator and it's a 0-length string, and thus the result is potentially ambiguous. You could be doing it accidentally with that thing.
Not really, because when you called this thing, you could have checked to see if it was 0. Yeah, but I'm saying it's not ambiguous. It's simply saying you weren't allowed to pass in 0 before. Now you are. So before, if you passed in 0, never mind ambiguous, your program, bad things happen. Like crazy things happen. So I don't agree with that. Yes?
We've lost the opportunity to catch our client's mistakes early.
I love that. Let's just look at this. How about that? This is likely to mask a defect because that is exactly right. That's this. Right. And more code runs slower. And I just want to point out that even if the code doesn't execute, that it's in the instruction stream means there's more code to get. So even if you put some code in a switch statement where the switch statement, the end of the switch statement, the default case never occurs, it's still more code, and more code does not run faster, it runs slower. Now, never mind that, we have an if statement. So we have to be a little bit concerned. In this case, it's the masking of the defect that's the problem. The code running slower is secondary in this case, in this particular case. But not, yes?
It also has the problem that if this function ever has to be implemented, it's no locked in that part.
Okay, so what was just said is we're limiting our options to extend it later reasonably. Right? That's an excellent point. That'll be in the quiz afterwards.
Did you say that a narrow contract implies that you will test for preconditions?
I know what I'm saying. I'm trying to give a distinction between what's wide and what's narrow. There are implicit preconditions in every function call, like the computer is plugged in. We don't mention that in the contract. And there are a lot of things like that.
So just saying that it's narrow doesn't mean that you're necessarily going to check.
Okay, so when you say a function has a narrow contract, it makes no statement whatsoever about the implementation when it's called out of contract, and that's required. That's absolutely mandatory. Because as soon as it does, it isn't narrow anymore. Okay, good. It's really good stuff. Can't believe how fast we're going. Usually people are, arguing vociferously at this point. So we must all be in, happy agreement. All right, good. So this is undefined behavior, and this is a narrow contract because it can go away. Whether it's there or not doesn't change the fact that it's a narrow contract. That kind of goes to your point, right? Okay. Just don't pass 0. All right. Now, another case. Set date, int. I deliberately made this look hard to read so that I could ask the question, should this return status? No, it shouldn't. Why not? Excellent. Absolutely not. And why? That's my birthday. Well, I know my birthday. I know that's my birthday. No one is going to argue me out of that that's my birthday, so I'm not going to check the status. Right? But of course, this is what I was supposed to do. Okay. So as a result, we get what's called a double fault. We can't defend against it. You had a, yeah.
So this is a relatively solvable problem by forcing the compiler to not allow you to ignore them.
Okay.
Great advantage.
So but that's a static analysis tool. That's not in the language as is. We love static analysis tools.
Even your types in this case have been a little bit better. You're taking 3 hits. That's a little bit tricky.
That's a what?
It's a little bit tricky. You're taking 3 hits. It's way wider than what you should.
Well, now this is a separate discussion. We could start to do things where we have something called year, and we convert an int to a year, and then we convert an int to a month, and we convert an int to a day, then we put them into this thing. You know what? That's just a whole lot of work, and you can still make the mistake because you can start cut and pasting that code around because it's too much to type in.
But your month could have been an unsigned car, for instance.
My month could have been a what?
An unsigned, and you an 8-bit UInt, for instance.
I'm not hearing you. It could have been a what?
An 8-bit UInt, for instance.
A string?
No, an 8-bit
Why would I want it to be an unsigned int?
an unsigned car.
Why would I want it to be an unsigned car?
Because it's between 0 and 12.
Okay, this is a separate discussion. In another discussion, we would talk about the notion of value semantics and algebraic types and then vocabulary types. And we would say, I want to have exactly one vocabulary type for every abstract mathematical Platonic type out there so that I don't have interoperability problems. It matters not at all whether the thing coming in is a char or a short because it's going to expand to an int anyway on its way in. Okay? That's the integral promotion. That's been like that forever. So that is not where you use char. And unsigned is a different algebra than int. The literal 5 is unsigned, but it's an int. It's not an unsigned. And it's not an unsigned char because it fits in a char either. Just so you know. That is another story. Let me not get started on that. But this is a double fault. And yes, I made it a little bit difficult. What I would do in real life is I would say set year, month, day. That would be the name of the function, followed by 3 integers for year, month, and day. That's really what I would do. But I did this to make another point. But yes. So returning status implies a wide contract, and wide contracts prevent us from defending against this in any build mode. So we don't want to do that. Now, if we look at this, how expensive do you think is compared to just setting these 3? In this case, by the way, the data members would be short and a char because together they take up 4 bytes. So there, yes. But notice the interface is int. Now, we would say set date. We would say set year, month, day. That would be the name of the function in the date class. But if we do this here, the assert is very expensive compared to this. Maybe an order of magnitude more. Because it's got to do some work. Whereas this other thing is just boop, done. Does that make sense? This would probably be an inline function. Okay. Does it? So you see that's very expensive. In a narrow contract, it's checked only in debug mode. But if we make it a wide contract, it's checked every time because when you don't know if the date is valid, you must check it. And if you do know the date's valid, you don't want to check it in case you're wrong. Now, that's kind of weird. If you know it, don't check it. If you don't know it, you must check it. Okay. So now we have this other thing that's sitting right next to setDate called setDate if valid. Guess what? If valid is a big clue that you better check the status. And when you see the two sitting there, you make the right choice and life is good. Now this is checked at every build mode. And you did that deliberately because it's never the case that you're going to get all the bugs out of your program and everything's going to just work. Okay? Now, what should happen here? There's this other function called at. It is my least favorite function in C++. Very least favorite. I regret that that ever made it into the standard. And what's worse, when you implement it, it's typically got some sort of exception thing in line with the code that adulterates all of the code around it and makes code run really slow. You can work around this as long as you have a function somewhere, a real honest-to-goodness function and a .o where the exception is thrown through. Then you can fix this problem. But until you do that, not so good. All right. So anyway, this depends on the build mode. This happens every time. You know I don't like this, so we'll just move on. Now this is a true story, I swear. What should happen here when index is less than 0 or greater than length? I had two people on the phone with me in the UK, both of them disagreeing with me and disagreeing with each other. What do you think should happen? Okay, throw an exception is not what they suggested. One of them suggested this. If it's less than 0, just make it 0. And if it's larger than length, just make it length. And the other one chimed in, no, that's ridiculous. Just mod it the length plus 1. No? Okay. Needless to say, I was not happy with either of them. What is that? Oh, thank you. All right. So anyway, more code runs slower. This is nonsense. And it's undefined behavior and no. All right. So now, what we really would do is we would check to make sure in the right build mode that this works. And unfortunately, if you're having some medical software or whatever, bad things could happen. So we have to talk about this. And as I said, in the next hour, we're going to talk about the solution to these problems that will make everybody in the room, I hope, happy. It's a challenge, right? There are a lot of you might not agree with each other yet. You will. Appropriately narrow contracts, narrow but not too narrow. So replace is an example of a function. Well, you can replace everything. But is it okay, if you replace everything, so say you've got something of a given length, what happens if you want to replace nothing at the end of this sequence? It's kind of a weird thing to ask. Suppose you have an index of 5 and a length of 0. Should that work? In other words, should we say, wait a minute, that doesn't make any sense. It's a no-op, just make it undefined behavior. Just say it's not allowed. But the trouble is, if you do that, then somebody who's trying to figure out if what they're getting is valid has to do an extra if. And your implementation would have covered it naturally. And so the point is, since it will cover it naturally, and if you look at how this works, you've got this nice triangle here, it's just better to leave it in. It's a little bit wider than it needs to be, but it doesn't matter because you're not writing any more code. You're writing less code. You're making the client write less code. It's fine, as long as it happens naturally. As soon as you start saying, I want to go one past the end of the thing and copy -1 elements, then you've lost it. But if you say, I'm going to start at the end and copy 0, that should work, just for keeping things natural. Contracts and exceptions. Preconditions always imply postcondition. That's absolutely true. If a function cannot do what it purports to do, then it has to not return normally. Now, I put this in here just so people could read stuff that I'm not going to talk about. The last thing I want to say, abort should be considered as a possible substitute for anything if you can't, let's say you're built in an exception-disabled mode. Now, it's not C++. There are embedded systems. People do this. And once you get to the point where if a function can't do what it's supposed to do, the last thing you can do is return normally. I'm just saying that. That cannot happen. And finally, there's this notion of exception neutrality. And we do something even a little stronger. We have something called exception agnostic. And exception agnostic really does mean, I don't know if they're exceptions, but I don't care. Because what I'm going to do is I'm going to acquire my resources, and then if I've got everything I need, I'm going to build an object, and that object is good to go. And instead of really calling it RAII, which is resource allocation is initialization, we have something called RDAD, which is resource deallocation is destruction, which is just really a guard going out of scope. But it's basically the same idea. And by never catching or throwing in our library, but making sure that we propagate injected exceptions using these techniques and not rethrowing and all of that stuff, our code is cleaner, it's no slower, it's sometimes much faster, and life is good. Any questions? All right, here's some questions. And we're going to stop after this because we're at a very nice stopping point. We got through 3 of the 5 things without killing each other. Just tell me if this makes sense. Would I, oh, that sounds like a good question. Some of what behavior are we talking about? We're talking about abort? We're talking, or what example precisely? I don't know. This one. Okay, the contract says the behavior is undefined unless 0 is less than length, 0 is less than num elements, and index plus num elements is less than or equal to length. That's the contract. Okay? This has some asserts in there that reflect the contract. But that is the contract. This is not the contract, right? The contract is in words, sits with the declaration. That's the implementation. Okay? Going back, back to here. So given that we're almost out of time, I'm going to ask specifically this question. What should happen when the behavior is undefined? Should what happens be part of the component level contract? Does everybody know the answer to this? The answer is no, it should not be part of the component level contract. Because as soon as you make it part of the component level contract, it's not undefined behavior anymore. It's defined behavior. So please, if you take away something from this talk, this section, take that away. You can't document undefined behavior. Because if you do, it's no longer undefined behavior. Is that true? There you go. Yes?
Could say the Microsoft implementation of the standard library function that says certain things are undefined, say, we happen to solve it this way, but we...
Absolutely. Once it's undefined, there are no wrong answers. I heard that today.
Right. That would be documenting it.
You don't document it in the contract for the function right there. What you do is you have a general waiver that says Microsoft does some other things. The trouble is when you have a standard, it becomes the standard becomes the contract. And the code becomes, even the declaration becomes the implementation of the contract in some sense. Because the standard is the specification. And the code must satisfy the standard or it's not compliant, right? That would be a fat interface. We would not want the standard to become fat, right? Okay, yes?
So in practice, if you are changing an implementation in ways that are allowed by undefined behavior and not covered by the contract,
They could change from one run of the program to the next. And often do.
right? Do you? I mean,
What do you mean, do I?
in providing libraries,
Yeah?
like, do you randomize those undefined results?
I absolutely don't randomize them. They're random enough as it is already. No, I don't randomize them. This is not a security thing, no. Absolutely not.
Changing, if you're doing refactoring on some library results.
I feel no compunction to go tell people that the undefined behavior has changed. It's new undefined behavior now. It was old before, now it's new. No, we don't do that.
And that plays out okay?
Well, you have to come to the next talk to see how it plays out. Anyway, I'm going to stop here because we're really about right at time, right? We're going to start really sharp in 15 minutes because the next, I have Oh, shoot, we're on through only 193 slides, and I have about 650. So we're going to have to go a little quicker.